section 1.1, and throughout this course, we're going to need to be familiar with the angles and how to measure them and where they're located on a coordinate plane. And we're measuring angles in two ways, in degrees and also in radian measure. And we want to be able to convert between the two. So first, let's talk about degree measure. This one is typically easier to calculate or to use in calculation, and also the one that we're more familiar with. So I'm going to start with the coordinate plane here. So an x-axis and a y-axis. And my starting point is my positive x-axis, so that's going to be 0 degrees. So as we rotate and create angles here in the coordinate plane, we want to think about just like we're drawing circles. If I draw one complete circle, make one full trip around here, back to the positive x-axis, I've made one full circle, that's 360 degrees. So 0 and 360 degrees, if I were drawing them, look exactly the same, and we call them coterminal angles. So here, my quadrants of my coordinate system, each of my quadrant angles, so the ones that fall on the axes, are just a fraction of the full circle, so a fraction of 360 degrees. And you can see the coordinate plane is split into 4 even pieces. So each of the quadrant angles is a fourth of 360 degrees. So here's what I mean. If I rotate from the positive x-axis to the positive y-axis, so I have an angle that looks like this, and that is 90 degrees. 90 is 1/4 of 360. So if I took my whole 360, I divided it by 4, I get 90 degrees. So each quadrant is a fourth of 360. So each quadrant is 90 degrees. So I go up to the top, I'm at 90 degrees. If I come down to the negative x-axis, I've gone 90 more. So I went from 0 to 90, going another 90 gets me to 180 degrees. So a straight line is 180 degrees. If I go 90 more, then I end up at this next axis, the negative y-axis, and that's 270 degrees. And if I went 90 more, that puts me at 360. And I could continue this forever and ever, infinitely, to get more angles. But we call these the quadrant angles, quadrantal angles, the ones that fall right on the axis. Quadrants on the coordinate system are measured counterclockwise. So the one where both x and y are positive is quadrant 1. And moving counterclockwise, we've got quadrant 2. Down here is quadrant 3. This one over here is quadrant 4. They're labeled usually with Roman numerals, and I think that's just because there's usually so many numbers on a coordinate plane, so just to distinguish it from all the other numbers. Right, so if I needed to locate an angle, for example, like 35 degrees. 35 is between 0 and 90. So the angle, 35 degrees, should fall somewhere in the first quadrant between 0 degrees and 90 degrees. If I wanted to find 200 degrees, 200 is in between 180 and 270, so it should be in quadrant 3. We know that negative angles are measured in the clockwise direction. So let's take a look at some negative angles and where they may fall. So I'm going to draw a new coordinate plane here. And let's label this one clockwise. So this is still 0 degrees on the positive x-axis. And so if I'm rotating down in the clockwise direction, so now my negative y-axis, the bottom, is negative 90 degrees. So we're just rotating in the opposite direction to get the negative angles. This is negative 180 degrees. This is negative 270 degrees. And this is negative 360. And we could continue on counting by 90s in the negative, so in the clockwise direction. So if I needed to locate negative 156 degrees, So rotating in the negative direction, so clockwise, I have to go past 90, but not past 180. So somewhere in the third quadrant. All right, so let's go back to our positive angles. And while we're here, let's talk about coterminal angles and how we would find them. I'm going to draw an angle here, maybe right here, halfway between 0 and 90. So halfway between 0 and 90 is 45 degrees. So this is a 45-degree angle. And if I were asked to find a coterminal angle to 45 degrees, a coterminal angle, if I'm drawing it, would look exactly like this one. But maybe I'm rotating an extra time around the circle. So you can see from the green arrow that I drew, it's much more than the first angle the arrow that I drew for 45 degrees. So this angle has to be bigger. And so what I did was I made one full trip around this circle. So I went 360 degrees from 45 degrees. So to find a coterminal angle, you just need to add or subtract 360 degrees. So if I did that with 45 degrees, I would end up with 405 degrees. So these two angles are coterminal. Their terminal side is in the same place. I'm drawing them. Other than the spiral arrow, they look the same. Same initial side, same terminal side. So sometimes these problems give us a certain range that they want the coterminal to fall into. So they say maybe find a negative coterminal angle. So adding 360 is always going to give me, well, in the case of 45 degrees, adding 360 degrees to 45 degrees is going to keep giving me positive angles. If the directions specify that I need a negative angle, then I should subtract 360 degrees from 45 degrees, and then I end up with a negative angle. If I subtract 360 from 45 degrees, so I'm doing 45 minus 360, I get a negative 315 degrees. Let's look at the negative angles here. Negative 350 degrees, you can see it's going to fall in the first quadrant, same as 45 degrees, and it is halfway between negative 270 and negative 360. So this is another coterminal angle that would look like 45 degrees. So 45 degrees, this one that we found, the positive one that we found was 405 degrees. And negative 360, not 360, sorry, negative 315 degrees are all coterminal. So next, let's talk about measuring angles in radians. So the definition of a radian measure is something that we may not understand at this point, and that is okay. We can still solve all of these problems without the true understanding of this definition. I didn't understand it for a long time. So the angle, the measure of this angle, as long as the length of the radius is exactly the same as the length of the arc of the crust of this piece of pie, then the measure of that angle is 1 radian. So in radian measure, our starting point on the x-axis is still 0 radians. We don't usually use, sometimes you write the word radian for units, but if you don't see any symbol, you don't see the degree symbol, then you need to assume that the measure is in radians. So starting on the x-axis, that's 0 radians, and one circle, one full trip around the circle, one full revolution in radians is 2 pi radians. So 2 pi radians is 360 degrees. So just like with the degrees, each of these quadrant angles is 1/4, so it's a fourth of the 2 pi. So this time, if I took 2 pi and I divided that by 4, now we're going to end up with some fractions. But reducing this, that's pi over 2. So each piece, each quadrant angle is pi over 2 of the full circle. So if I go up to where 90 degrees was, in radian measures, that's pi over 2. The negative side of my x-axis would be another pi over 2. So there's two ways that you could do this. So you could count like 1 pi over 2 and then 2 pi over 2 and 3 pi over 2. Or if you prefer, you can add. So you could do pi over 2 plus pi over 2. Either way, we end up with 2 pi over 2's, which is going to simplify to just pi. So this appears 1 pi over 2. The next one should be 2 pi over 2. And you can see 2 pi over 2 simplifies to pi. So I'm going to write it as pi. Okay. So then the next quadrant angle is 3 pi over 2. And then continuing on, we will get to 4 pi over 2. And you can see that 4 pi over 2 simplifies to 2 pi. And you could continue counting them this way. So going back to the top, after 4 pi over 2, you will get to 5 pi over 2, and then 6 pi over 2, and just reducing them as you go. Because of the fractions, it's a little bit harder to see where angles fall that are in between these, because you have to know, like, is pi over 3 bigger or smaller than pi over 2? You have to think about those things. I'll show you how I find an angle. So something that has a different denominator than 2. I usually try to compare it to pi. So 1 pi, if I'm thinking in 6, would be 6 pi over 6. If you're thinking in 4, so it would be 4 pi over 4. So if the number in the numerator and the denominator match, that's going to simplify to 1 pi. So if I'm trying to find 5 pi over 6, comparing it to pi would be 6 pi over 6. So it's a little bit less than 6 pi over 6. And it is more than pi over 2. Pi over 2, that's half. So I'm thinking in 6, half would be 3 over 6. So it's more than that. So less than pi, but more than pi over 2. We're in quadrant 2. And let me label these in 6 just so that to make that more clear. In 6, this would be 3 pi over 6. So remembering like how you get a common denominator with fractions, here to turn a 2 into a 6, we will multiply by 3. So you get the same thing on the top and the bottom. Multiplying the top and the bottom by 3 gives me 3 pi over 6. Over here, I want the denominator to be 6, so I gotta multiply the top and the bottom by 6. Okay, so if I make the denominator match the angle that I'm given, now it's a little bit more obvious that 5 pi over 6 is in between these two. So 5 pi over 6 is in quadrant 2. So let's do another one. Let's say maybe, so thinking in fifths, pi would be 5 pi over 5, so that's way too big. Let me think about pi over 2. What would that be if I want the denominator to be 5? And this one, it's hard to convert directly because I can't multiply by a whole number and turn a 2 into a 5. However, I know half of 5 is 2.5. And this, what I have here is just 1 pi over 5. Right? So it's not going to be half. 1 over 5, that's less than half. So going to be less than 5 over 2. This is going to fall in quadrant 1. Once we learn how to convert between degrees and radians, you may find it helpful in the beginning to take the angle and convert it to degrees and then locate it on the coordinate plane. But if you're pretty good with your fractions, you usually can try to reason and figure out where these angles fall. Let's do one more, something negative. We haven't talked about any negative angles. Let's say a negative 2 pi over 3. So let's go back and label these negatively. All right, so this time rotating down, clockwise direction. Pi over 2 would be down here. So this is negative pi over 2, negative 2 pi over 2 is pi. This would be negative 3 pi over 2. So now we need to find out where is negative 2 pi over 3. Numerator and denominator kind of close together, so I'm going to compare it to pi because I know negative pi would be negative 3 pi over 3. Numerator and denominator match. Okay, but it's less than that. So I'm thinking it's somewhere in here. I'm going to double check, just make sure that it is bigger than pi over 2. And it is. I kind of think of that like 2 is more than half 3. So it's going to be bigger than pi over 2. So falling somewhere in quadrant 3. To find coterminal angles and radians, it is the same process that we used in degrees. In degrees, we added or subtracted 360 degrees, which was 1 full revolution. In radians, 1 full revolution is 2 pi. So we're going to add or subtract 2 pi. Okay, so we talked about angle 5 pi over 6, and this one was in the second quadrant. So let's find an angle that's coterminal to 5 pi over 6. To do this, we need to add 2 pi if we want a positive angle, or subtract if we want it to be negative. So we need to remember how to add fractions, add with fractions, and to add or subtract with fractions, we need a common denominator. So we're going to have to rewrite 2 pi so that the denominator is 6. So if you need to, you can think about 2 pi as 2 pi over 1. All the numbers go over 1. And I want to multiply by something on the top and the bottom. But my goal is to change this 1 in the denominator into a 6. I want denominator to be 6. So we're going to multiply on the top and the bottom by 6. And that is going to give us, so just write in the 5 pi over 6. That's going to make this 12 pi over 6. We can double check. If you simplify 12 pi over 6, you get 2 pi, so they are equivalent. But now with the same denominator, I can add the numerators and treating pi just like a variable. So if that's at 5x plus 12x, we would get 17x, so 17 pi, keep the same denominator. So 5 pi over 6 and 17 pi over 6 are coterminal angles. Okay, so 5 pi over 6 was over here. And just for practice and to kind of double check, let's think about where 17 pi over 6 would fall. And it should be in that very same spot. So looking at this angle here. All right, so I'm going to start. I want to kind of think of some angle that's close to 17 pi over 6. That's one of these quadrant angles. So it's definitely bigger than one trip around the circle. So bigger than 2 pi. So I want to think, well, is it bigger or smaller than 3 pi? And because the denominator is 6, what would 3 pi be with the denominator 6? So I'm going to multiply by 6. That will give us 18 pi. So it's pretty close to 3 pi, but less. Where is 3 pi on the coordinate plane? Well, we've got 1 pi over here. 2 pi is where 0 is. 3 pi is going to be back over here where pi, and 4 pi is back over there with 0. Okay, so 3 pi is over here, and 17 pi over 6 is a little bit less. So it seems very reasonable that it's coterminal with 5 pi over 6. So just kind of double checking myself, thinking about where, even if I don't know exactly where 17 pi over 6 is. No, it's in that second quadrant. It's close to the x-axis, but definitely less, so above. And it seems reasonable that those two are coterminal.